So now we're going to answer the question, what is a root? And you'll figure out that roots are they're basically are exponents. So we have special roots, just like we had special when the index is 2 or 3. Remember, we had x squared or x cubed. Same thing with roots. When the index, it looks a little different in a square root. This is the index here. For a square root, we don't write it. So if there's nothing there, it's assumed to be 2. That would be a square root. And when there's a 3 in the index, we call it a cube root. So what do these roots mean? Well, roots are just a really nice way of writing an exponent in a form that is a fraction. So, for instance, if I had the square root of x, not the x root of 2, the square root of x, this is equal to x raised to the second power. Raised to the 1/2 power. And the great thing here is now we can just use all of our exponent rules, which we'll do in a minute. But I want to make sure that we can make it clear here that if I had the cubic root, well, that would just be x to the 1/3. What if I had x to the 50th root? Well, that would be x to the 1/50th. Let's look at what if it wasn't an x? What if there was more underneath there? So if I have a square root of x plus 3, everything under the root is going to be put in parentheses. So we're going to have a parenthesis of x plus 3. This parenthesis is replacing that square root sign, and it's going to be raised to the 1/2. So if I had the square root of what if I had this? X plus 3 squared plus 7 squared. Now, a common mistake is, I have a square root. I can just square root the 7 and then break it up into something like this. But that doesn't follow. And the reason it doesn't follow is because this whole thing is being squared. It's not just this part or this part, it's the whole thing that's being squared. So this is not the same. These are not the same. So what this is the same as is the square root of x plus 3 plus 7 squared is going to be equal to x plus 3 plus 7 squared raised to the 1/2 power. How would we solve this thing? Well, we would just say x plus 3 plus 7 squared is 49, and this is raised to the 1/2 power, which would be equal to x plus 51 squared, or to the 1/2 power. Okay, so this is our final answer. Let's go back here. What would we get if we solve this? I want to prove that these are not the same. So we're going to have the square root of x plus 3 plus square root of 7 squared is it's going to be 7. See how we can't move back in to the argument at all? So this is not correct. Let's go further a little bit. So now we're going to go in and get our let's rewrite our exponent rules. I want to go through those and how we would deal with them. So we have a to the m times a to the n is equal to a to the m plus n. we have a to the m over a to the n is equal to a to the m minus n. We have a to the negative 1 is equal to 1 over a. We have a to the negative m is equal to 1 over a to the m. We have a to the m times a to the n is equal to a to the m times n. We have a over b to the m is equal to a m divided by bm. And then we have a b quantity raised to the m is equal to am bm. So all these rules apply for the square roots. So let's take this one. We have square root of x times x squared. What's going to happen here? Well, the first thing we're going to do is we're going to take this root here and make it a fraction. Multiply it by 2. Well, what's going to happen is that we're going to use our exponent rules right here. We have something of an x to the 1/2 times x squared. If we broke this down, we could think of it as x times x times x to the 1/2. We could count the index up, right? We could go 1, 2, then we have a 1/2 here, so we don't know what to do here. That didn't help us though, because this is just a 2 over here. So you'll find once you get further, you're just going to have to use your exponent rules. You can't break things down anymore, and you should just only use the breakdown for proof and just use these rules to shortcut and save yourself time anyhow. So what we're going to do here is we're going to use our exponent rule, which says if they're being multiplied, the multiplications between them, we're going to add x. We're going to add our index. So 2 plus 1/2. And that's going to be, well, wait, we got to get a common denominator. The common denominator doesn't change no matter where it's at. So this will be 2 times 2 over 2 plus 1/2. The 1/2 gets to stay. X. That's all being raised to the power x. 2 times 2 is 4, so we'll have 4 plus 1 over 2. This is going to be equal to x to the 5/2. Now, how would we write that? Let's put it back into a root form. Well, the denominator is a root, so we can write this as x to the 5th squared. If we want to. And we could think of that as being true, because if we have x to the 5 right here, this would be like having this x2 here is the same as root of 4 root 2's. We add another one, we'll have 5 root 2's. If you didn't see that, you would look at it like this. X squared times root x is going to be like square root of x. Well, let's break it down a little further. It's going to break down into x times square root of x. This is going to be, this will be square root of x times square root of x is equal to one of these x's. So remember, multiplication's commutative, so we could have an index over the root of 1, 2, 3, 4, 5. This would be root x raised to the 5th power, and that would be equal to, remember, x to the 1/2 raised to the power of 5, which is equal to x to the 1/2. We're going to use our exponent rule right here to give us x to the 5/2. So there is us using our exponent rules. And when you're using roots, they're just going to be a fraction, and then you're just going to use your exponent rules from there on. So there's a few exponent rules the book has really tried to get you guys to know. So square root of n to the a is equal to a to the 1n. That is one of the rules they want you to know. Then we have, in the book they put an m here, so it would be m to the n. The next rule is n square root of a is equal to b if bn is equal to a. We'll go over this one a little bit in the next video. I'm going to talk about basic steps of algebra. And then we have square root n, a over b is equal to square root n of a over square root n of b. And this, if we go back up here and look, this is the same rule as, let me find it here, as this one. Copy this and paste it down here. These are really the same rule. We have this exponent, remember, is just a power, so this would be a to the 1 over n. B to the 1 over n is equal to ab to the 1 over n. We just use these rules in conjunction with each other. And that's pretty much all on exponents. Well, it is exponents, but this is pretty much all on roots. I think I pretty much addressed everything here. So that'll be it. Next we'll be doing steps of integration. Not integration. Whew, not that far. We're going to be doing steps in algebraic evaluation.